So good evening, everyone, and welcome to our consulting project and event. This is actually our only second time having this event in person, so we're so excited to see all of you here and to have a bit of a crowd this time around. So as you're probably expecting, we're going to go through the consulting journey of some of our project groups this evening, and you're going to hear a little bit from our partners as well. So the overall agenda for tonight, we're going to give you a brief overview of Emergent Consulting in case you're not one of our student consultants or partners. And then we're going to allow our partners a chance to tell you a little bit about what they do and how they have helped and contributed to our projects and mission. And then our project groups are finally also going to present their projects that they've been working on for 8 weeks now and the solutions that they came up with. And now I'm going to hand it over to Alexandra to tell you a little bit about Emergent Consulting.
Yes, welcome from me as well. So what it is that we do in Emergent Consulting projects, we have 3 important stakeholders, namely our students, clients, and our partners. And in the middle, there is Emergent, bringing them all together. So we have small groups of students that are working on a data science related project for our client companies, and on their consulting journey, they are assisted by the expertise of our partner companies. And how do we execute our consulting projects? Well, our consulting student teams of 5 to 6 students work on a project for 8 weeks, approximately working 1 day per week. And they have their client and partner meetings weekly or bi-weekly. And on top of that, our partner companies organize different workshops for them in order to elevate their data science skill set even further. That being said, I want to wish a warm welcome to our first partner for tonight, Bright Wolves. Bright Wolves has been with Emergent ever since our first days 2 years ago. They have been of indispensable help to our student consulting teams, and Simon from Bright Wolves will tell you more about what Bright Wolves is and what is it that they do. Welcome, Simon.
Thank you. Welcome, everybody. So my name is Simon. I'm a manager at Bright Wolves for a bit more than a year now. So I think I'll briefly introduce you the company and what we do. So Bright Wolves, in a nutshell, is a management consulting firm. We were created almost 5 years ago. We'll be celebrating that milestone in January. And we are oriented around 3 different axes. So the first one is what we call the business tribe, is where we do all the strategy and finance consulting. The second one is the sustainability, where we help our companies become more sustainable in their operations, doing LCA analysis and other roadmaps, or help them designing their engineering and products to be more sustainable. And finally, the reason why we are here is the third tribe, which is everything related to digital transformation. We are also supported by 2 other companies in our group. There is a DigitMint, where we are developing software solutions, which we generally identify, thanks to our consulting in the digital transformation tribe, problems that repeat themselves and every time require a custom solution, we turn them into a software. And finally, Quantim, which is a network of experienced professionals which we can leverage when needed. So in more details, well, I think I already mentioned this, but it's really the subdivisions of the 3 different tribes. But let's look a bit more at the clients we serve, right? As you can see, we have a lot of clients both in business and digital transformation, a bit less in sustainability. Why? Because, well, it's more recent that we are active in this field. The way we envision digital transformation is actually as a more global technological transformation journey. And actually, it never stops, right? Some companies, they are still at pen and paper today. It's hard to believe, but yes. And well, as they go through their first step of transformation, they become digital. So they start to use computers, they start to create data. As they have more and more data, they have a new problem, which is, well, there is data, you need to manage it. Which is why we have our data pillar, which is all about managing the data, governing it, all the engineering, creating the pipelines. I think you all know how to do that. And finally, once the data is all sorted out, well, that's when the fun starts, and you can start to leverage it with advanced analytics, using AI, doing dashboards, and defining how you will move forward and go through a new stage of digital transformation, where this time you leverage data to transform your business model, and then you can start again the cycle. So some example of projects we're doing. I will maybe just mention one project I'm working on at the moment. So I'm finishing a project where we use natural language processing to treat pharmaceutical data, turn the biomedical keywords that only doctors understand into a database well structured, so that we can then use a language model to generate questions and interact with patients through some kind of chatbots to get their input. Another project is to work at the moment. I'm working at the moment on the implementation of the analytical roadmap in a major yogurt manufacturer, to not name him, where we define really what are the data needs, how to structure it, and we create a whole system, the whole backbone to generate, to leverage the data so they know how to pilot their company. Right now it's a quite urgent need as inflation is increasing, so they need to know where they stand and how to price their product to still make a profit but not lose market shares, etc. So quite interesting. But yeah, if you want to know more about other projects, feel free to talk to me at the end of the presentations. I'll be happy to share more projects that we've been working on. So in a nutshell, Brighttools is a very value-driven company. So those are the values we live by, and we put a strong emphasis on the company culture, really living as a family. It's hard to say, it's easier to live it, but yeah, really something strong compared to other companies. I know as a student you don't have much experience, you don't know what are different cultures, but once you live them, you know how to recognize a good one. So we are, for the moment, about 50 consultants, which are really moving forward, can-do mentality. We have about 100 clients, and we started a few months ago our first international expansion with the first office in South Africa. So the way we tackle consulting is that we don't generally create a whole team of consultants with like the partner of the manager going to the client and showing himself as being the expert, while the consultants are doing the work in the backyard, let's say. We take the things the other way around. We push consultants in front of clients from the go, interacting with C-levels from the start. And as we call the pyramid principle, the consultant is at the top, but he has the whole organization behind him to help him solve all the problems with a strong emphasis on learning, coaching, etc. So what we offer is a steep learning curve. It's not a company where you just sit in front of your computer and wait for a year and nothing happens. We promise projects where we actually deliver impact. What matters is the results. And finally, we are a very entrepreneurial company. So the South African expansion, that's one example. We opened a bar recently, bar restaurant recently. It was empty. We seized the opportunity to open it because, well, we wanted a place to have at lunchtime. And we created a lot of other initiatives recently. Always crazy idea that turned into reality. Finally, well, I normally have a few slides about our events, but some of you already came to one of our events, which we did some time ago. Then we had the case day, but all that is done for the semester. The next events are yet to be planned, but will be next semester. Meanwhile, as it's difficult for me to explain you the culture in just a few minutes, we actually have a culture book where you can read the testimony of everybody individually and see their experience and who they are and what they do. Thank you.
And just before you head off, Simon, as a thank you for working with us for the last 4 semesters at this point and being such a valuable resource for our students, we have just a small little gift basket to hand over.
All right. Yes. Thank you.
Thank you again for that introduction. So next up, we have one of our projects, something that most of you are probably interested in hearing about. Our first team worked with our client Colibri on a project that they're going to tell you more about. So I'm going to invite the Colibri team up here for their presentation.
Imagine you have a website for real estate and you have a lot of user activity that the customers visit this website, look at all these houses, all these rentals, to buy, to rent. So you collect a lot of data in this website which summarize the user activity. So how can you utilize this data to improve the customer experience? So in this project, thanks to Colibri and Bright Tools, we try to utilize all this customer data, all this user activity to segment customers. So using customer segmentation to improve the customer experience. And we try to tackle this, problem as a team. We started like 8 weeks ago, as they mentioned as well. And we looked at a lot of different things. So this is our team. And to just to give you some information about Colibri, just something that Colibri is a powerful personalization software for real estate portals and websites, and they provide us a vast amount of data that they really helped us through all the data analysis and the project as well. So in this project we try to utilize all these data to enhance customer experience by identifying and examining all these customer behavior and try to cluster them, try to create segmentations. So our problem was, like I said, we received a lot of raw and processed data that includes all these, website activity with different websites. So we have, for example, what type of, activity how much time did this person spend in this website? What type of activity was it? Did they go into detail? Did they go into pictures? Like that kind of stuff that helps us identify these customers and their behaviors. And then, after analyzing this data, we, try to, our problem was to get some meaningful insights on this data and create some segmentation. So then, after, this data, we try to make some meaning of it. And our roadmap, like I said at the beginning, we tried to read and analyze this data, did some cleaning, and then, doing some literature review, feature engineering, which we'll be going to detail later. Then, we did some clustering and tried to create these segments. And I'm gonna now hand it to Adam.
Thank you. So initially, to familiarize ourselves with customer segmentation as a whole, we tried to look at what literature was out there actually. And we found that in terms of customer segmentation, there tends to be an overwhelming focus on demographic and geographic segmentation, and generally in accordance with preference to goods. For example, the automobile industry is really big into customer segmentation, and there it was focused on things such as the make or the model of the cars. And indeed, those that were actually real estate focused were also really very focused on the actual goods, in this case the property. So what kind of properties are they, how large are they, how much do they cost? But so in general, the literature wasn't terribly helpful on the topic side. However, what it was helpful in was actually creating a coherent way to build the models. And in particular, choosing the clustering algorithms. For example, this significant paper by Depari compared different clustering algorithms and see which ones perform the best in terms of customer segmentation. K-means came out on top. And then there were also these 2 other papers, which although dealt with supervised learning as opposed to unsupervised learning, actually dealt with trying to predict customer behavior in the real estate market. And in this regard, familiarize yourself with what we are really dealing with. These 2 papers use an interesting approach where they compare the national identification number of people in Sweden and then together with the data from real estate companies found out actually who was a buyer of properties and then worked in reverse to see how they behaved on the website. We also wanted to find a little bit more about Colibri's performance in general, just so we get more context to the figures we'll get later on. So we found out, for example, that a bounce rate of almost just under 30%, about 30% of users have only one event on the website. This means over 70% of users that get on the website actually proceed to viewing properties or viewing other pages. And as we see by a study done by Siege Media, a prominent SEO company, Colibri actually performs very well in this regard. On the other hand, just under only 10% of users actually come back, have more than one session and return to the website. And finally, when we actually exclude the users who just go to the website and go back, they have on average 8 events per person. So, according to the literature review, we structured our methodology accordingly. First of all, creating the pipeline, defining the features, preparing the data for unsupervised learning. We will go into all of this more in detail further on in the presentation, just a general overview of how we proceeded with the problem. And then finally, something that's quite important as well, our literature review was key in cleaning the data, where we actually narrowed down 128 columns into 13, and these 13 columns really contain the most important features and data that we then used to create these clusters. Now I will hand over to Raphael to explain more the analysis.
Thank you. All right, I'll talk a bit more about the specifics of our data processing and data cleaning. So we received from Colibri a very large data set of a whole lot of columns, basically, and every column is an event of some kind of user, something they did on the website. But we, of course, are interested in user clustering, so we wanted to look at, instead of looking at columns where every column is an event, we want that every column is a user. So with the help of a pipeline given to us by Colibri, as well as our own pipeline and contributions to that, we created one complete pipeline to run the data through and basically have our new data sets on the user level to be used for clustering later. To give you an idea about how this data looked, on the left you can see the original data. This is not the real data, of course, but just an example, where we have some columns that are features given to us, user IDs, something they did on the website. And when we run it through our pipeline, we get a new data frame where every row is a user, and we perform some calculations on top of that to get new features such as percentage and stuff like that, but I'll talk about that in the next slide. So here are the 13 columns that we use for our clustering. 13 columns when we analyze the data that we thought are of the biggest impact for the clustering. First of all, we have some information about events of a user. We can determine for some user the amount of time, like the amount of events that are happening on their phone or on their desktop, so percentage of what device is used, as well as percentages of from what other website they come. So if they stay within the website and click on another link, it's an internal refer, but if, for example, if they come from a social media website, it's a social media refer, and things like that, as well as more detailed explanations about the events themselves. If they click on a lot of pictures, we can determine how many of those events are on pictures, how many events are on details of the properties and things like that. And we also have some more features, more regarding about the user itself. How many sessions does he have on the website? How long does he spend on average on the website? How many events per week? And when we run it through our pipeline, we get these columns on the user level, and then afterwards we can start clustering, and Simon will explain more about this.
Okay, I'll talk a little bit more about the technical part. After doing some research online, we found that k-means was one of the best clustering algorithms to use in this case. We had this input vector of size for 13, like we explained before. These are the 13 different columns we use as input. We normalize the data because, of course, it works better on a model normalized data. And then how the k-means algorithm works, it needs a value, the k value. And the k is actually like how many clusters you get. At the right, you see a graph, and it's called like the method is called the elbow method, and it graphs like how well the model is performing at a certain number of clusters. So I ran it 30 times, and the point of this is to find the k value. The k value is actually the elbow, so like where the curve stops going down drastically, and in this case it's around 8. Now this number that comes from the elbow graph is no specific number. It doesn't have to be like 8. You can go down or up a little bit. It depends on the case you are in. The problem with this, the regular k-means algorithm, is hard to cluster high-dimensional data. We ended up with using 13 columns, but at the start we were using more than 40 columns, so we had a hard time doing the clustering. That's why I looked online and found a new method. Well, actually, it still uses the k-means method, but it uses an autoencoder. The autoencoder is a neural network that consists of 2 parts, the encoder and the decoder. And it has an input, again, of size 13. And it tries to scale down this input to a vector of size 8. That's the encoder part. And the decoder part tries to scale it back up again as to the original data. OK. I can explain it more clearly when you use an image, for example, as input. You give an image as input, you try to compress it to a smaller size, so it's easier to deal with, easier to compute things on. The compressed image still has to keep all the relevant information, like colors, certain edges, and then it tries to scale it back up again. But for the k-means algorithm, we don't need to scale it back up again, so that's why we only used the encoder part. For the autoencoder, we also got a loss of around 1%, so pretty low. It performed pretty well. To do the actual clustering using the autoencoder, we passed all the data through to the autoencoder and fed it to the k-means algorithm. Again, we used the elbow method, and as you can see, the blue line is with the autoencoded data. It's way lower. The lower is the better, of course. It's way lower. The k value we got from this graph was around 3 again, but we, after doing some analysis and trying different k values, we found that k equals 5 is the best, and we ended up with 5 clusters. Then I'll give the word to Batwan.
Okay, so now that we have our clusters, we now have to make them meaning, because now that what we have is all these 13 columns and 5 different clusters. So each cluster should have some meaning to have like meaningful data inside. So we have a lot of clusters. So we now started to interpret these clusters. So we looked at we defined our features. So we looked at these features and how do they differ in each cluster. So for example, in time spent and the longest session, here we can see that the cluster, the second cluster has like the highest time spent here and also has the longest session, so it has like its own distinction. So we can like interpret on this and call this cluster like more serious shoppers, which I will explain again. And we also have like activity features. So for example, how many, which percentage of the activity is from phone or desktop. So for example, even though the second, this one was the highest time, the phone activity is like lower. So, this also, tells us something. And we also looked at like the events per week, and like we analyzed all of our clusters, and we defined some characteristics, and then building upon these characteristics, we, decided to, give these clusters meaning. So to go, one by one. So for cluster 1, we realized that the average time, the time spent here is like average, it's like median among these clusters. So there is like it is not the highest time spent, but these users have a lot of high percentage of detail and picture in the website. So even though they don't have like much time spent, when they do, they like go into details and pictures. So we decided to call this cluster 1 that is like the average and regular shopper. So these are like not the most serious customers, but they regularly go into website. So the second cluster is, as I said, it has the highest time spent, and in these times they go into a lot of details and pictures. So these are clearly the serious shoppers. They are the ones that are gonna buy the house or rent a house, so something like that. So these are the serious ones. And the third one is, like I said, it has a lot of phone users and social referrers, which is, which makes sense in our context. So these people mostly go onto the website around like 80% go onto the website on their phone, and also looked at and come through social media and social referrers. So other than the internally, they go more through social refers, and there is a lot of picture activity rather than detail, which also supports the social claims. So we call these like social shoppers. They are like browsing on their phone, like they're looking at the pictures, they're looking at all these different things, but they don't spend as much time as the other clusters, but they are still looking, and they are on their phone. So this is like serious social shoppers. So we can customize the website according to their needs. So they are like different. They have like different characteristics according to compared to other clusters. So the clusters. In the cluster 4, it has the highest search percentage. So most of the people come to this website come through like searching on their own, like not through ads or anything. So the referrals are like mostly search and not like social media. And it also has a second highest time spent, other than the cluster 2, the serious one. And the cluster 5 is the time spent here is the lowest, but when they do, it's not too low, but it is like lowest among these 5 clusters. But when they spend some time on the website, they go into detail and pictures a lot. Like the activity itself is like, it has some sort of seriousness in it. So we call these 2 clusters potential shopper for cluster 4 because they have the second highest time spent. So they are potential customer to buy house in the future, but they don't spend as much time as the serious one. So they are like potential, but not so serious. And the last one is future shopper. We decided to call this like future shoppers because like they don't look into houses, as much as the other clusters. But when they do, they go into detail. So this kind of tells us that when you're looking for a house or something, if the deadline is approaching, you go into the website a lot more. But when there is like still time, still like months left, you kind of looked at like some locations, some houses and stuff, but after that, like you kind of don't go into detail. So we decided to call these future shoppers. So using all these characteristics and the results of our cluster, we decided to create, our 5 customer segmentation, which was our end goal at the beginning. So like I said, average shoppers, serious shoppers, social shoppers, potential shoppers, and future shoppers here. And to conclude, what we said. So at the beginning, we received all these, raw and processed data of a website that explains all this user activity that has a lot of features, a lot of raw data. And through our pipeline and then through K-means autoencoder model, we created these 5 segments. And to finish our presentation and just to reflect, throughout this project, we learned a lot about how to utilize data and how to do data analysis in like a business project, in the business context. Like how can we utilize these data insights into a business context? So we learned a lot about during this project, and we also want to thank Colibri and Brightos again for their help and all the coaching that they did. And for future work, like I said, this is like a one method of clustering. Different methods, different classifiers always could be implemented. And also different like time steps. How can one person go from one cluster to another can be analyzed for future work. So this is the end of our presentation. Thank you so much for your time, and thank you so much for listening.
If you have any questions for our team, you can ask them at our reception later. We want to thank you for all of your time and effort, and for that we have a small gifts for you, as well as a gift basket for our client Colibri. Yeah, and for the technical difficulties, well, what would a data science event be without a technical difficulty? Next, we have our second and last partner of this semester, Möbius. Möbius has also been with Emergent Consulting projects for a long time. This semester, Vard, and in front of Möbius, has worked with my consulting projects, and I can really say that they've been an essential part of our consulting journey. Vard will take you over what Möbius is and what they do.
Great. I'll try doing it without microphone. My voice tends to be loud enough. If you think that it's too quiet, just give me a hand and then we'll continue. Okay, Möbius, as you see, quite experienced guy standing in front of you who will tell everything about our company. So hook on to the right. What is Movies? Movies is a company of 25 years old. We have about 110 employees at the moment, and we're active actually at 4 locations. We're active in Ghent and in Brussels. We also have an office in the Netherlands, and we have one in France, a small one there. And we're really active across a lot of different actually sectors, like we're active in industry, in healthcare, in the public sector, you know, like every other firm, you're always everywhere active and you always have a lot of projects. Some of our customers, for example, I'm active on the Johnson & Johnson project, which is a very big project we're having in that team. But there are others here as well. We're together with Barco, we work together with, for example, in Society, the Flemish government. We were kind of big in the COVID vaccination project, where we actually made the allocation model that allocated all of the vaccines to like all of the centers. An example of a package of a project, that we also did is we created a model that allowed for some 3-dimensional bin packing for stock rooms. We did it in Colibri because and also we did it also, like you see here, in actually in hospitals, because that allows to really optimize the way they pack and store everything in their rooms there. Other projects as well. You see, I'm kind of going through this presentation because I don't really like these slides. Let me tell you why I think that you should go for Mobius. The reason why I like Mobius is because it's a very open company. Even though you're very young, even though you don't have much experience, they give you a lot of opportunities to grow. For example, we work with like a specific system of how our company is structured, where there is not a lot of hierarchical boundaries actually. You have a lot of circles, and you just step into every circle, which is a specific domain of interest, and you get projects there, and you work on several projects, and you learn a lot through that method. And I know these slides are classic slides that you see everywhere, but I think that is really the strength of Mobius, that they give you really a possibility to go wherever you want. You're not like the junior consultant and you do whatever the big boss is saying you, and you have to wait for 3 years until you get an opportunity to grow a bit in the organization. No, you really get a lot of autonomy, a lot of own, let's say you can take action into your own hands and really try to find your own path into the company. So we are active on analytics, we are active on the domains that you are interested in. If you want more information about that, ask me. But what I want you to take away with this is really, if you want a company where you have time to grow, where you can really do whatever you would like to do, and where they even encourage it to take up as much responsibility as you want and as you can, join us. We're active in Brussels and Ghent, like I mentioned, so all around Belgium, and I'm sure you will like it. All right, thanks everyone for listening.
Thank you, Ward, and Mobius in general, for all of your help over the last 1.5, 2 years. And as always, we have another gift basket. Woo! And next up, our final project for this semester. I'm going to invite my Crefin folks up here. Take it away.
I'm starting.
Or whoever's starting.
Can I not use the microphone?
Please do for the recording.
So we have Okay, welcome everyone to our presentation now as well. We worked with a startup called Crefin, and we'll take you through our project now. Yeah, through this presentation, you'll get to meet the team. You'll see what we did, what problems we faced, and how we attempted and solved them. But first, here we have the team that worked on this project. We had our Alexandra, our leader, and then Kinga, Konstantinos, Dian Young, myself, and Clemon, which, yeah, you'll see all of us through the presentation. To understand a little bit better what Crefin does and what we had to deal with, let's first introduce Alexandra. She's a courgette farmer somewhere in central France. And what she really wants to do is expand her business from not only courgette to something else. But for that, she needs money, which she currently doesn't really have. She could go to a bank for a loan, but you know, banks are tricky, you require a lot of paperwork, and in the end, you need to pay back expensive interest rates usually. And this is where a company like Crefin could come into play. They provide a buy now, pay after harvest service, so Alexandra could get raw materials, raw seeds, manure, whatever she needs, and would only pay that after she sells the new produce she grew. And that would all come with 0% interest rates and 0% fees, which is perfect for a farmer like Alexandra, who is not very wealthy at the moment. So Crefin would take a courgette farmer like Alexandra from just one business sector to growing broccoli as well, making her business more stable and such. So now you see what Crefin does. Mura will tell you more about the actual project and what we dealt with and what problems we faced.
So the original idea was that we wanted to have the data from the company and build a model that will predict whether the farmer is going to pay back. So the risk of the default. So as it happens a lot in life, there is expectation and there is reality. And we expect that the company will have all the data that we need, and then we just build the model and we select the best performing model and we're done. But it's not easy. The reality is that we had to look for our own data, and at the same time, while one part of the group was looking for the data, the other part was already looking for data that is suitable the most, so that we can start building the model and get some ideas what kind of variables might be interesting to look at. And for the modeling part, Konstantinos will explain more.
Thank you, Mura, for the introduction, and I want to thank my whole team for their cooperation. Okay. Like we said, reality hit us, and we tried to find an appropriate dataset to work on. And we looked into Kaggle, and we found a dataset that is very suitable at first look for our purpose, because it has financial ratios that we show in the research are important for this kind of application. And the response variable is the credit rating of companies, so it's very useful for us. And we started with modeling. The first model we considered was logistic regression, which we show is the benchmark for this type of application and also offers very good interpretability. The second one was the k-nearest neighbors, which is very easy to utilize, very good in general, offers good out-of-the-box performance. And the third, and best of all, as you will see, was the gradient boosted trees, which is also very suitable because this type of problem has very huge imbalances, and this model combats that because it reduces bias in the predictions. At this slide, you could say, what is he talking about? These models are the same. K-nearest neighbors is better. So why to add the complexity of the boosted trees? Well, if you look at precision, you will understand why. And precision is very important for this problem because precision is the portion of correct classifications of correct. And correct in our case is that a company that will actually repay. So if you look at the logistic regression, the first row, only 50% of the companies will actually repay. And this is very crucial because our client wants to minimize their financial loss. So you see why boosted trees is much better. 90%, 90% of the time it gets it correct. At this point, reality hit us again. because unfortunately this dataset is not perfect. Why? Because our client wants to work with small French farmers, and this dataset has to do with big American companies. But we try to do our best and gain the most value from this modeling. And then Kikna will continue with the other course we took. Thank you.
Okay, so as it was mentioned, like we didn't have the best data we could work on, so we had to look on our own for something more appropriate for our clients' needs. So more specifically for like smaller companies in France, but I think it was the most underestimated like part of our project. So the time and the effort we actually needed to find anything. So we like approached like two main problems, which may sound a bit trivial. So the first is the availability of the data, and the second one is the completeness of the data. However, these two problems, like they played a big role in our project in general. So first, it was not only about looking for the very specific data in every possible resource we could actually like get, but even sometimes when we found something, at the end, we cannot use the data for many reasons. For instance, the data were like, we were not allowed to use the data because of some geographical reasons. For instance, we couldn't use the data from the US, and even if they were about France, because we were not allowed to. Second problem was even sometimes when we saw a good source of the data, the price of the data itself was just very high. So there was like, it was not be meaningful or useful to use the data. And when it comes to completeness, so even when we get the data at the end, we had to reject them because most of the variables were just missing, and we have like a lot of empty rows. So we could not use them to build any model. So just to like show you how broad was our like approach, we started looking in Google Scholar in like different research papers to see what kind of data people are using. Maybe we could also reach them, but it was actually it was less meaningful than we thought it will be. Then we went to Kaggle. Later we focused on more specific databases like Orbis. Orbis is a database that contains information about different financial ratios across the world and about companies. And then we went to Papes. Papes is a database specifically for France, but also contains the information about the finance status of the company. However, even at the end, when we combine all the data and all the like different resources to get like one data set, like the best one, there was still one problem to solve. The data was not labeled, and our previous model was provided on the labeled data set. So now Mianyang will tell a bit what we did to solve this problem.
Thank you, Kinda. So already sure we can use supervised learning to predict the credit risk based on supervised learning. But in the real situation, like the data collected from the Orbis and papers, they are unlabeled data. So which means we can't use any supervised learning, but we can still do something with unsupervised learning, such as we can use unsupervised learning to detect some abnormal companies. So like the figure on the right, so if we project the data onto 2-dimension by plot, the different data point represents the different company, and the yellow data point represents the majority of the company. We can also observe two black points, which are very far away from the majority of company, so they are the outliers. So these outliers companies have very abnormal performance associated with credit risk. So this means this company we should pay more attention to, and also we can extract these kind of companies, and we can do further studies with our external financial knowledge to increase our knowledge about credit risk. So we have one additional data set. We reduce the dimensionality with our domain knowledge and also dimensionality reduction technique. And for some methods, such as the figure I showed before, the outliers are already very clear to be detected, but for some techniques, the outliers are not very easy to be detected. So we continue use some clustering method and also outlier detection techniques. And finally, we got 11 strict outliers, which means this kind of outliers are detected by the majority of the method. And we also get 35 flexible outliers, which are the outliers, or the total number of outliers detected by all the method. So in the future, we can just extract this outliers company and have a detailed look one by one, or mix them together, so we can get some useful information related to credit risk. So, this is the last part of our project. We already show the problems we faced, and we also show how the method we were trying to handle it. Next, Clement will show what we can learn from this consulting project.
Yes, so to wrap up, we just wanted to mention the key takeaways that we got from the project that we built from the start, because like my colleague said, we had to collect the data and to find which kind of ratios were interesting, and we managed to collect some data from potential French clients for Crefin. And we really experienced that data science is about data, is about preparing data, but was also about complaining data, and to be adaptable and creative to find multiple sources, multiple solutions like we did with different sources to tackle a problem. And would like to end with a funny note that there are two kinds of data scientists: those who can extrapolate from incomplete data. Thanks.
Thank you for all of your hard work. We have small gifts to thank you. We also have a gift for our client Crefin. Thank you very much.
That brings us to the end of our presentations. I want to give one final thank you to this wonderful team up here that made all of this happen and has worked tirelessly since probably June or July. Bass in the back, our lead clients, who worked really hard to secure all of our projects and clients. He's been in contact with all of our clients. Marios, lead CP events in the back, who's organized all of our team buildings and the reception that you guys are about to attend. Ada, Alexandra, and Diego, who couldn't be here, our lead projects, who did an amazing job leading their teams. And then I realized I also forgot to introduce myself at the beginning. I'm Anya. Hello. I just do some paperwork on the side. Also, shout out to Lucas. He's not here, but he also worked with our partners. So thank you, Lucas, if you're watching this on the recording.
To stay updated with all of that we have left for you in the future, follow us on all of our social media, join our Facebook community, and now I would like to invite you to our reception. Try our sangria, it's good. And see you next semester.